All right, and to recap, we are on key question number 2, what factors influence the size of the human population? And then we are going to wrap up with the different demographic transitions that tell you where a country is in the least developed to most developed scale. So let's get back into it with fertility rates. So population is also measured by fertility rates, which is definitely more positive than thinking about death rates. So our fertility rate is the number of children born to a woman during her lifetime. And there are two important fertility rate numbers. Pardon, bird again. The first is the idea of a replacement level fertility rate, which is the average number of children a couple needs to have to replace themselves. Now, as a reminder, there is still a very low infant or child mortality rate in even the most developed countries. So a replacement level fertility rate in more developed countries is around 2.1 children per couple. And in less developed countries, because they have a higher infant and child mortality rate, their replacement level fertility rate is 2.5 children per couple. Now, you think, okay, so if we got to a fertility rate of 2.1 or 2.5, would that halt population growth? The answer is, in fact, not for a while. That is the whole idea of lag, which comes into just about every biological system. That as of right now, even though there are, we're talking about fertility rates for the current number of women and couples that are at a reproductive age. There are still all of those little girls underneath the age of, we'll say 15, that are alive right now, that will grow up and have children of their own. And so the population will continue to grow once we've hit that replacement level fertility rate until all of the children that are alive right now have replaced themselves. So that's your replacement level fertility rate. But then we'll move on to total fertility rate, or TFR, which is the more emphasized number or measurement. That is the average number of children born to a woman in a population during their reproductive years. So how many babies does a lady have once they've hit reproductive age until menopause, when they stop being able to reproduce? So since 1955, looking at the 2010 numbers, the TFR in more developed countries has dropped from 2.8 children to only 1.7 children. And in less developed countries, it's dropped from 6.2 children to 2.7 children on average. So this is a good trend, and we should continue this trend, but we are not quite to the level where our TFR has gotten to the point where we have leveled off or reached a stable world population rate. All right, so let's take this knowledge and then apply it to how countries go from being considered less developed to being more developed. This is talking about demographics and how we transition from a less developed or pre-modern country to a more modern or most developed post-industrial country. So this graphic right here shows you a transition model for just any old country that you can think of. Most of the countries in the world are at various stages along this graph. You start out with stage 1, which is pre-modern, stage 2, urbanizing and industrializing, stage 3, mature industrial, and then stage 4, post-industrial. And we will talk about what all of these things mean. Keep in mind that your blue line is your crude birth rate, your red line is your crude death rate, and your black line is your total population. So our first stage is our pre-modern stage, or otherwise known as the high stationary stage, because it is characterized by a very high but relatively equal crude birth rate and crude death rate. This causes a lower level but more stable population. A doubling rate for this population would take anywhere from 1,000 to 5,000 years. And this is typically following a type 3 survivorship curve. Survivorship curves, tying into things we already went over. Let's review just in case you forgot. So, survivorship curves, there are different types. Type 1, type 2, type 3. Type 3 is characterized by low survivorship in the younger age groups, with a higher survivorship level the older a organism in the population gets. In this case, we're talking about humans. Type 2 means that there's pretty steady survivorship no matter what age you're at. And then type 1 is high survivorship through up until you get too old to survive and die. So, remember, these are the different type of curves that I'm going to be referring to as we continue. So, stage 2 is urbanizing or industrialization. You see a transition from a lower crude to a lower crude death rate, and which is shown by the red line dropping over time, and a birth rate that stays just about the same, or in some cases rises a little bit. This creates a population boom, as there are just as many babies being born and surviving, and more babies surviving and less people dying as they get older. Because of this increase in infants and children surviving, we go from a survivor 3 curve into a survivor 2 curve with a steadier survivorship over time. Stage 3 is the mature industrial stage. Your crude death rate continues to decline, then even out, and you also start seeing a decline in the crude birth rate. The population continues to boom, but is moving towards a stabilizing as the birth rate is declining. And our survivorship curve continues moving from the stage 2 survivorship curve towards stage 1. This brings us to stage 4, which is the post-industrial stage. We have a very low crude death rate and crude birth rate, but they've kind of started to equal out again. The population is stabilized at a higher level, and you have a survivorship curve 1. Now, you may be thinking, okay, I understand how survivorship curves apply to different species, but how do we actually see this reflected in more developed versus less developed countries? And so I will show you. Here we have a graph detailing the survivorship in Niger, India, and Great Britain in 1999 versus 7th century England. Now, the survivorship has been divided for each country into male and female survivorship. So let's talk about, first of all, 7th century England. You see this very steep type 3 survivorship curve with a lot of people dying before they reach the age of 15. And then gradually over time being able to survive at a higher rate as they are getting older. You look at Niger, and it does not follow quite as an extreme type 3 survivorship curve because of medical and nutritional advances, but you still see that sharp drop in the survivorship percent surviving in the ages 0 to 10, and then it starts to even out as they get older. India is transitioning between being a less developed into a more developed country, and so you start seeing it have a more flattened, evened out, moving towards type 1 survivorship curve. And finally, Great Britain, a more developed country, having a type 1 survivorship curve, with most people surviving up until you get old at about 65, and people really start dropping off. In all of these cases, you can see that the females are doing better as it when it comes to living longer, and that's something that we'll talk about later on. So at this point, we've reached the end of the lecture. There is an assignment, and specifically for this class, if you've been taking notes this entire time and have been pausing the lecture to be able to get the notes in, that's fine. I still expect you to have the assignment done and turned in tomorrow, along with the lab that you mostly completed on Monday. I hope you had a wonderful day, and I will see you guys tomorrow.